We've looked down our code with SaaS, scrubbed our secrets, and fortified our Terraform infrastructure with OPA. But then comes the final vessel before production, the Docker container. Most developers think, hey, I put my app inside a container, it's isolated, it's safe. But let me shatter that illusion. A container is not a magical force field. If your base image is rotting with unpatched CVEs, or you're pulling arbitrary Linux package from the public IPs, your container is just a Trojan horse waiting to be opened. Today, we are breaking down container security, image scanning, and SBOMs software bill of materials from the ground up. Let's dive in. Look at this Dockerfile. Seems harmless, right? To a beginner, latest means give me the newest best stuff. To a security engineer, latest is a ticking time bomb. You have no idea, but OAs, packages, glimpse versions, or critical vulnerabilities are backed into the base image today versus tomorrow. Even worse, people run containers of the root user inside. If a hacker manages to break out of your Node.js app, they don't just compromise the app, they own the entire host machine. We need a way to inspect every single layer of that container image before it ever sees a container registry. Enter our next defense, the harpoon. In the real world, this is Trivy, Grype, or Aqua. When your CCD builds a Docker image, the image scanner doesn't just look at your app code. It rips open every single layer of the container file system. It reads the package managers, checks the binary files, and cross-references them against global vulnerability databases. If your base image has a critical remote code execution flow, the scanner drops the anchor and kills the build. It says, no, you are not pushing this vulnerable image to Docker Hub or AVA's ACR. It's fast, automated, and non-negotiable. But modern supply chains require more than just knowing what's broken. You need to know everything that's inside your ship. That's where the SBOM comes in software bill of materials. Think of an SBOM as the ultimate ingredient list or blueprint for your container. Every library, every transitive dependency, every system package is cataloged in a machine-readable format like SPDX or CycloneDX. Then a new zero-day vulnerability drops next week. Your security team doesn't have to guess if you're affected. They query your SBOM repository in 2 seconds. They know, service X use log4j version Y. It transforms emergency response from blind panic into precise surgery. This is how you secure the final meal of your software delivery pipeline. You stop using latest, you scan your container layers, and you generate an SBOM for every single build. So when an interviewer asks you, how do you secure containers in a CI/CD pipeline? Here is your gold standard answer. We pin our base images to specific digest instead of using lattice and avoid running container as root. We integrate container image scanners like Trivy or Grype into our C pipeline to block builds with critical CVEs. We automatically generate an SBOM software bill of materials for every artifact to maintain supply chain transparency. That is how you secure the containerized frontier. If you want the exact CCD configuration files for Trivy and SBOM generation, check the description below, hit subscribe and drop a comment on what we should conquer next, and keep your containers IoT'd. See you in next one.